So what we had was a cloud of gas and dust collapsing in on itself, forming the sun in the center, a big flat disk around it out of which all the planets were forming.
There are all kinds of vast clouds of dust and gas floating around the galaxy. What actually causes them to start collapsing and forming new stars? Well, you have to give that cloud a push.
Scientists think this push could be a stellar blast, a supernova.
Supernova are some of the most powerful events in the universe. One explosion can light up brighter than a galaxy. So not only do they eject elements and material, they also eject a lot of light and energy.
A supernova explosion sends a shockwave racing out into space at 18,000 miles per second.
The shock wave from a nearby supernova compresses material together until it begins to collapse under its own gravity.
Was this how our solar system started?
So far, it's been really difficult to find evidence that there was some supernova or point to something that happened that really kick-started the solar system.
The ancient supernova blast faded away a long time ago.
Imagine a crime scene. Now imagine waiting 4.6 billion years after the crime is committed and looking at it and going, there's nothing here, what are we doing? That's kind of what we're trying to do here.
Researchers from the University of Minnesota tried to solve this ancient crime by studying asteroids that fell to Earth as meteorites.
Asteroids are critical for understanding the early solar system, and this is because they have frozen in place all the conditions that existed in that very early solar nebula right at 4.5 billion years ago.
The asteroids contain information about the time leading up to the birth of the Sun and the solar system.
When a massive star ends its life as a supernova, it undergoes what we call nucleogenesis. In fact, we call it explosive nucleogenesis. Literally, the explosion is generating new types of nuclei, new elements, heavier elements. Well, it turns out the types of elements it makes depends on the star that blew up.
The Minnesota team ran computer simulations to investigate which elements form when a star, up to 12 times the mass of the Sun, explodes. Then they compared the results with analysis of elements found in asteroids dating back to the birth of the solar system. They match.
So the remains of the supernova was actually under our noses all along in the elements that have been in our solar system for ages.
And perhaps in the Earth as well.
The Earth has lots of rocks that's made of silicon. That's only produced in supernova explosions. And the very core of our Earth, the thing that keeps us alive, that's iron, nickel. Again, you only get that in supernova explosions.
In February 2021, scientists shed light on the supernova explosions that helped seed our solar system and provide the materials to build our planet. The researchers examined fragments blasted off the giant space rock, Vesta, 4.5 billion years ago, and later landed on Earth. These asteroid fragments contain the fingerprints of not one, but at least two supernova explosions.
Our solar system was seeded, was enriched by at least 2 separate supernova explosions. That's incredibly lucky because that is what delivers the ingredients necessary for life.
Scientists believe that these two supernovas may have enriched different parts of the infant solar system. One provided the materials that help form the outer gas planets. The other supernova seeded the inner solar system with elements that built the rocky planets, including the Earth. And the scientists think they can even tell the type of supernovas responsible. One was a core collapse supernova, a giant star that likely lived in the same stellar nursery as the Sun. It ran out of fuel and collapsed in a huge explosion. We think that this supernova fed the outer solar system. The other was what we call a Type 1a supernova. It's caused by a small white dwarf star cannibalizing another star.
What we think happens is that a white dwarf has a companion star, which is either another white dwarf or a bigger star like a red giant. And the white dwarf accretes matter from the companion star.
If they accumulate too much mass, they can reach a critical density, forcing them into a runaway supernova event.
The Type 1a supernova explodes with extraordinary force, blasting material across interstellar space, donating elements to the heart of the gas cloud, where the inner rocky planets will form. Once again, our fate came down to pure chance. A series of extraordinarily violent supernova blasts gave the solar system the kickstart it needed and the elements to build the planets, without destroying our future home.
It's a fine line between being too close to a supernova, which will just shred your pre-stellar cloud,
And not too far away that you don't get any of the good stuff. Supernova play both creation stories and destruction stories. They play both roles.
We lucked out. This chapter of the story ends well. The solar system gets the ingredients it needs to build planets. Earth forms in a good location, close to its star. The future looks bright. But then, the biggest bombardment in history smashes into the Earth. From the moment our planet formed, we've been under fire. 2021, a fireball streaks across the night sky in Europe. 2018, a 1,500-ton meteor explodes over the Bering Sea with 10 times the energy of an atomic bomb. 2013, an asteroid explodes over Russia, injuring over 1,000 people.
The Earth is hit by quite a few asteroids every day. You see them as shooting stars, meteors in the sky.
These events are violent and destructive, but these space invaders also brought something every living planet needs: volatiles.
When we say volatiles, what we mean are elements that are really light and easily moved around. Often they're gases, so that's oxygen and water and carbon dioxide and just all those light elements that are really important building blocks for life.
These elements are abundant on our planet today, but were not when it first formed.
From observing other solar systems forming all around us in space, we know that planets as close to their stars as we are to the sun, when they form, they're very hot and dry. There's probably some little bit of water around there, but really not very much.